Welcome, ladies and gentlemen, to another edition of solving algorithm problems on codewars. And if you're new to Binary Life, this is a channel that teaches some developers how to code. And while coding, you can learn the approaches that are brought about to bring to life the solution and how the thinking process goes on. Without much ado, let's get into business. Today we'll be solving a 6Q kata, which is about finding a grid position. Okay, so if you're given, let's try to understand the exercise. Your task is to implement a function createGrid, which takes three parameters, m, n, and position. M is the number of rows, n is the number of columns, and position is a point, x and y axis, something like that. Now what do you have to do if we're given something like that? Grid position 5 rows, 8 columns, and the position x3 and y2. What do? You are going to produce a grid like this, and at this position x3, y2, considering that there are 0 indexes, it starts at 0. It's mentioned somewhere. Give me a minute. Right, position indexing starts at 0. Okay, so we produce something like this. At that position, we are going to insert x. So x, we are going to insert the star, and where the star intersects, we are going to put 1 on the horizontal row and 1s on the vertical row. So what does that mean? We have on the y-axis, y is 2, which means those are the rows, 0, 1, 2. And position x equal to 3, we put the star. Without much ado, let's get to solve. But before that, there are some clauses. Sometimes you might go out of bounds, like here for this particular example. Here we have a grid of 5 by 5, but we're asked to insert at this position x8, y0, the star. Meanwhile, at this position, it doesn't exist in a 5 by 5 grid. We can't have a column with eight elements because it's a 5 by 5 grid. So since it's out of bounds, we're going to insert just zeros. Okay, so let's try to break this down. And one more thing, we're returning the answer in the form of a string like this, one long string. So I'll start by creating a solution variable that's going to have the solution. Since we are expecting a string, I'm going to put it to be an empty string. And since we are in the scenario where we have a matrix that we have to build, I am going to create a for loop that we are going to start from the rows. I'm going to start from the rows. Now the row starts at 0, and it has to limit at m, which stands for rows incrementally. Let's put it a singular because as we're looping at each line, we have one row. Something like this. Okay. Now once we're inside the row, we start looping through the column. Now column starts at 0, and while the column is less than n, incrementally, what do we do? Let's start by checking if we have an intersection between the rows and columns. So if the column matches the x-axis of the position and the row matches the y-axis of the position, then we have an intersection. So at the level of the solution, we are going to append the star. That's the most important. Okay, before going further, remember this second inner for loop matches the column. So at the end of the column, we break, we go to the next line. So at the end of the column here, I'm going to insert into solution the next line. We'll just keep concatenating because remember the final solution is a form of a string. We're going to concatenate the next line. All right, let's get back here. So while we are inside the same column, if we match the position, we insert the x, the star if you want. Else if we are give me a minute. Else if we are at the right column, now if we are at the right column but the wrong row, so if the column matches the x-axis, then that is where we are going to have the diagonal ones, not the diagonal, the vertical and horizontal ones. So we are not at the position. Oh, give me a minute, I have some aching issue here. I'm going to update later, remind me later. Now if we are at the right column, even though we are at the wrong line, we are going to insert the 1. Same thing is gonna happen if we are in the right row, that is the row matches the y-axis, but we are in the wrong column. At least we are going to have 1. That is then going to create the ones that surround the x, the star. I just keep saying x is the star. Actually, we're going to add the 1. Right at the end of all of this, you remember we loop through give me a minute. Just put it large screen. All right, that's large screen, and then I'll try to increase the size of the character. Okay, that's a little bit bigger. Right, remember this is the first for loop stands for the line. Now this is the second for loop that stands for the column. At the end of the column, we insert the line break to go to the next line. So that's why this line break, that /n, occurs directly at the end of the inner for loop. But if you look at our grid, by the time we arrive at the very last line of the grid, it is going to insert an additional line break, which we don't want for the very last line because that's the end of the grid. So what does that mean? That means that means we are going to return our solution without this very last line break that will occur at the end of the string. So we're going to return just a substring of the solution. So this will be the substring, the substring of the solution that starts at index 0 and ends at solution dot length minus 1. You can check the application and the documentation for substring, but basically it starts from here and ends here without this index inclusive. Now let's do a test so that you can see at the Node.js console. So if I have a string, I just call this my string, be equal to, I have let's just give it the word test. So if I say my string, I display just the substring starting from index 0 to index 3. What do we have? So it starts at index 0 t and gets from 0 and get the element from index 0 to index 2. So the 3 is not inclusive, so it's index 0 1 2. You see, it never got the last t, which is at index 3. That's it. So it will be from 0 to 2. That's it. So here we say from 0 to the last character, which means it's not going to include the last character. Okay, now let me also console log it so that we can see visually what the answer looks like. If I console log this before returning, what do I get? All right, let's run it. I've come out of the full-time screen, and then let's just run the test. Now let me bring back the police so that we can have the normal display of the codewars website. Okay, so let's, oh, there's a failing condition. Oh, this is the equal sign, the comparison line 9. Equal. Let's run the test one more time. We passed the test, but we failed something. Oh yeah, there is a final else condition now. Remember, if there's an intersection, we put the star. If we're at the right column, we put the 1. If we're at the right row, we put the 1. But if we're at the wrong row and the wrong column at the same time, we are going to add a 0. Remember, it's a grid that must be filled, so we're going to add a 0. That is why you can see here from the answer, we have 1s and star, but we don't have 0s that comes with it. Let's run the test one more time. Great, we are passing the test. Now let's attempt this. Right, so we have passed 70 and failed 51. Why so? Now there is something strange that I noticed when I solved this for the first time, which is the fact that they always fail in a scenario where there is no star. Why so? Now what I'm going to do is I'm going to console log the parameters that were given in the function so that you can see what's happening in the background. So m is this, n is this, and the position is equal to, now we have x to be positioned at x, and y to be positioned at y. Right, let's run that one more time, and let's attempt again so that you can see what happens for the final solution. Right, so let's go where there's a failure and understand why. Let's look for something that is red. Yeah, something like this. Look at this particular scenario here. Now we have m is 9, which means we have 9 rows. We can see that we actually have 9 rows here. Now we have n is 1, which means we have 1 column. So this is 1 column. This is very correct. Now we have to insert at position x0, y11. We have to insert the x, the star if you want, the star. Now it happens that something is out of bounds. There are 9 rows, which means that the y-axis should have just 9 lines. But we are asked to look for the intersection at the y-axis at position 11, which is not existent, so it is out of bounds actually. That is why it decided to, at its position 0, it decided to insert ones. It would have been 0 there. That's why we say it's expected zeros, but we have ones. So this solution has always been failing consistently when there is something out of bounds. Let's look at this other scenario here. We have 9 rows and 9 columns, so this is a perfect square if you wish. Now we are looking for the position at the y-axis, the fifth row, which is 0, 1, 2, 3, 4, 5. So that row actually exists. Now at the 11th column, we can't have 11 column here because it's a 9 by 9 grid, so there's an issue. So our algorithm is perfect for the case where we have been given a very correct position, but it fails when something is overbound. And on the exercise, we have been asked to take care of overbound issues somewhere around if the specified position is out of bounds of the grid, just return the grid filled with zeros. Let's come back to the output. So you can see that on the grid that appears here, there is no x because there wasn't a place, there's no star if you wish, there wasn't an intersection for us to insert a star. So let's come back to what we have to do right now. So what we have to do right now is I'm going to increase again the character so that you can see better. So what we are going to do is I'm going to create a constant and call it absent and bring it to -1. Now why am I bringing it to -1? If you check alright, this is a string here. This is some text I was running on the console. This is a string. Let string be this. Now if I look for this is how we look for the index of the star in that string. So you see it returns that the star is at position 8. Now if I search for the index of 0, it returns -1. -1 stands for the fact that inside this string there is no 0 at all. So that is the scenario that was happening in our squares. Since there wasn't any intersection, there was no star at the final solution. So I am going to check if inside our solution we have a star. So if the index of the star is different from absent, remember absent is -1, it's a constant. So if the star is present, this actually means if the star is present, then we are going to return the solution. That's when we have we are given a very correct position. Now if the star is not present, therefore we have to return a grid made up of zeros. So I'm going to just reinitialize solution to be an empty string, and I'm going to fill it with zeros. And remember, these are the filling algorithm were done for these 2 for loops. I'm going to copy the for loops and bring inside here, and I'm going to remove everything here. So let's start again one more time. Our algorithm runs perfectly up to this point here when we are given a very correct position. That is why I check if the star exists. If it exists, I'll return our solution. But if the star doesn't exist, it means the position that was given was probably out of bounds. So I'll just restart the filling process without checking things. I'll just do another 4 loops, 2 for loops, one under the other, and I'll just fill the whole grid with zeros. That's simple. And at the end of this else, I am going to return the solution. Now let's try to make everything clean by removing console logs. And let me remove in fact, I'll just comment this initial console log. Right. So this first scenario works when everything is, we're given a row and column are in very correct position. Else we just have something that's out of bounds, so we just fill with zeros and we return our grid. Right. So let's come back to our full screen, and let me make it smaller so that we can see the whole thing. All right, that's it. So let's run it one more time. Don't forget, I'm going to submit the GitHub solution on the description below, so you can check the whole solution on one page. Sorry for switching from screen to screen. Right, so let's run it. And let's attempt one more time. Yeah, and we've definitely passed the test. Alright guys, this was a very long scenario. It was a very long test. And let me just put it on one large screen. Right. So thanks for watching, and don't forget to always come back, as days are coming ahead where we'll be solving multiple algorithms. And I hope this has been very fruitful, and I would love to have in the comment section any amelioration that can be proposed, optimization hints for this algorithm. And till then, please don't forget to subscribe for more content, and thanks for viewing.